Good morning. In today's lecture, we're going to look at how we can take derivatives of products of functions and quotients of functions. So a product of a function might be e to the x times x squared. A quotient of two functions might be e to the x divided by x squared. So let's check these out. So if f of x and g of x are differentiable, the derivative of f of x times g of x is, well, we'll save the punchline for the end, because this punchline is a little bit surprising. I know that the derivative of a sum is the sum of the derivatives. I know that the limit of a sum is the sum of the limits, and in fact, that's what inspired me to think, oh, I bet the derivative of the sum is the sum of the derivatives. Well, we also have another limit rule which says that the limit of a product is the product of the two limits. So I would think that the derivative of a product is the product of the derivatives. It turns out that that's not the case. And typically we use, when you're looking at functions, we use f, and then the next one, if we have another function, we'll use g, and we use h. But I just changed my mind about this. I want to call this guy s and f. And the reason is it's going to be a little bit easier for us to remember later on, because f is going to stand for the first function and s is going to stand for the second function. So let's use those guys. So let's find the derivative of this. Again, let me give you a minute. Let's see if you can come up with the definition of the derivative if you're looking at f of x times s of x. Pause the video, give that a shot. Well, hopefully you said f of x plus h times s of x plus h minus f of x times s of x all over h. All right, so before we continue, let me just say that, let's say I didn't know what this derivative is. I mean, I do know what it is, but let's say I didn't know what it was. Again, with proofs, I like to think to myself, hey, what might I think should wind up in the answer? Well, if I'm looking at these two functions, I would imagine that the derivative of f of x should be in there somewhere. The derivative of s of x should be in there somewhere. I think that's a reasonable guess. It could be wrong, but hopefully the derivative is somehow related to the individual functions. So with that in mind, my next step is going to seem a little bit strange, but I'll explain why I'm doing it after I write it out. So I'm just going to copy over f of x plus h times s of x plus h. And I'll copy this over minus f of x times s of x. Then I'm going to do this mysterious thing where I'm going to subtract f of x plus h times s of x. And then I'm going to add f of x plus h times s of x. Okay. So before I tell you why I'm doing that, is this legal algebraically? Can I do that? And the answer is yes, because I'm subtracting and adding the same thing. I'm just adding a fancy version of 0, so I can do it. So the question is, why am I doing it? Well, if you look at these two guys, and you factor out the f of x plus h, you can see this is now giving me an s of x plus h minus s of x. And that's all over h. That's starting to look like the definition of the derivative for that second function. Similarly, if I look at these two guys, and if I factor out the s of x, I see f of x plus h minus f of x all over h, starting to look like the derivative of the first function. So that's why I'm doing it. It looks promising to me. Again, my initial thought was, hey, I probably want the derivative of f of x and the derivative of s of x somewhere in there. So let me clean all that up. So again, as I said, I'm going to take f of x plus h, factored out, and then I have s of x plus h minus s of x. So that's these two guys. Then here, Let me factor out the s of x. So we have factoring in s of x gives me f of x plus h minus f of x. And that's all over h. Now, just so I won't have to write this yet another time, if the whole thing is over h, we've seen this before, that's the same thing as putting this guy over h plus this guy over h. Okay, and then once again, we've seen this before, having this in the numerator is the same thing as multiplying it by the whole expression. Having this in the numerator is the same thing as multiplying it by the whole expression. All right, we know that the limit of a sum is the sum of the limits. So I could do this guy separately from this guy. We know that the limit of a product is the product of the limits. So I could do each of these separately and then multiply them. So I'm going to give you a minute. See if you could figure out this guy's limit times this guy's limit plus this guy's limit times this guy's limit. Give that a shot. Well, hopefully you said as h goes to 0, f of x plus h, well, that's getting closer and closer to f of x. Right? X plus smaller and smaller is getting closer and closer to x, so we're left with f of x. As h gets close to 0, s of x plus h minus s of x over h gets closer and closer to s prime of x. It's just the definition of the derivative for that second function. As h gets close to 0, s of x could care less. There aren't any h's in there. So this guy's just s of x. As h gets close to 0, this thing gets closer and closer to f prime of x. That's what it is by definition. So the derivative of f of x times s of x is f of x times s prime of x plus s of x times f prime of x. Now that's quite a mouthful, and quite frankly, I never think of it that way in my head. Instead, I think first times the derivative of the second plus second times the derivative of the first. Now, if this were a live lecture, I would make all of my students repeat this 4 or 5 times, both with their eyes open and their eyes closed. So I would invite you to pause the video, repeat this formula, and try to commit it to memory. Let's do an example with this. So let's say I want the derivative of x squared times e to the x. So pause the video, give that a shot, see if you can apply that formula. Okay, hopefully you said first times the derivative of the second, which happens to be e to the x, plus second, which is e to the x, times the derivative of the first, which is 2x. Piece of cake. Now think how difficult that would have been to plug into the definition of the derivative to actually compute it via a limit. This product rule makes it, way, way, way easier. Way easier. All right, so that is the product rule. So we just talked about what's known as the product rule. Well, as you might imagine, there's also a quotient rule, and that involves quotients of functions. So for example, x squared divided by e to the x. So let's check that out. So this is now the quotient rule. If t of x and b of x are differentiable, then the derivative of t of x over b of x is, and I'm using t and b for top and bottom. So let me invite you to once again pause the video, see if you can come up with the definition of the derivative for the function t of x divided by b of x. Well, hopefully you said the limit as h goes to 0, t of x plus h over b of x plus h minus t of x over b of x all over h. Okay, we've got to deal with this limit. The first thing that I'm going to do is I'm going to combine everything so that I get rid of this subtracted expression of two rational expressions. So how am I going to do that? Well, this guy here is missing a b of x over b of x. So I guess that's t of x plus h times b of x. This guy here is missing a b of x plus h over a b of x plus h. So this is going to be t of x times b of x plus h. And then, as I just said, the least common denominator, I guess I didn't say it, but I implied it, is going to be b of x plus h times b of x. So I gave this guy the missing b of x, gave this guy the missing b of x plus h, and all of that is over h. But if I'm dividing this thing by h, this is really the same thing as dividing by h over 1, which is the same thing as multiplying it by 1 over h. I can flip the bottom and multiply. So I can put this h here, get rid of this stuff, and let me just clean that up a little bit. Okay, so that's the limit that I am interested in studying. Now let me say that once again, if I didn't know what this answer was, if I didn't know what the derivative was, I would suspect that the derivative of t of x would be my answer. The derivative of b of x would be my answer. So I'm going to do another mysterious step, but the whole point is to make that happen. So what mysterious step am I going to do? So I'm going to first rewrite that first piece. So t of x plus h times b of x. Then the mysterious business that I'm going to do is I'm going to subtract t of x times b of x. I'm going to add t of x times b of x. And then rewrite the t of x times b of x plus h. And that monstrosity is still over the same denominator. So again, what I'm doing is this I copied, then I subtracted and added the same quantity. Why? We'll see in just a minute, but it's basically to get the derivative of t of x, the derivative of b of x in there. Subtracting and adding the same thing does nothing, so I'm allowed to do that. And then I just copy this guy here. Okay, so let's see. So if I factor out a b of x, I have a t of x plus h minus a t of x. Okay, so that's good because that has to do with the derivative of t of x. We've also got an h down here. So somehow those three pieces are going to combine into the derivative of t of x. And then over here, if I factor out a t of x, I'll have b of x minus b of x plus h. There's an h on bottom. That's just the opposite of the derivative of b of x, right? Because we want b of x plus h minus b of x. Okay, so it looks like the pieces are there, but it's not really clear exactly how that's going to work. So we need to keep moving on that. Let me do this one more level here. So let me do what I just said. So I'm going to factor out the b of x, and I'm left with t of x plus h minus t of x. So I just factored out b of x, and I have that there. I just said that this is going to be the opposite of what I want. So instead of factoring out a t of x, let me factor out a minus t of x. So if I do that, then I have b of x plus h minus b of x. Okay, that's starting to look good. I'm starting to see the derivative of t of x. I'm starting to see the derivative of b of x. And all that stuff is over h times b of x plus h times b of x. Okay, so let me start pulling stuff out. See what we could pull out here. Let's see, so I want to group these guys together somehow. And I want this stuff to be together also. Hopefully my circles are making sense. So these guys have nothing to do with the derivative, so I'm going to pull them out just so I can better see what's going on. So we have the limit as h goes to 0. We have 1 over b of x plus h times b of x. And I can already see I'm going to run out of room here, so I'm going to shift this guy this way. Okay. And then once I have that, let's see, what am I left with here? So I have this times this over this. So I have b of x times t of x plus h minus t of x over h. So I played the same game that I've been playing a bunch of times already. Since this is in the numerator, I just pulled it out in front. The h is just on the bottom there. And then we're going to subtract. Same game. So let's see. Looks like I can pull out the t of x. And that'll be multiplied by that b of x plus h minus b of x all over h. All right, so think about that. Make sure that all those pieces line up. Said another way, I mean, if I multiply through here, combine these guys, put it all over h times that, I should get this guy back. Okay, the limit of a product is the product of the limits, so I can take care of this guy by itself. The limit of a sum or difference is the sum or difference of the limit, so I can look at each of these guys. Limit of the product is the product of the limits, so I can look at each of those two pieces separately. So let's look at this then, term by term. So this is the same thing as, let me not write limit because I'm actually going to compute the limit. So as h goes to 0, this is getting closer and closer to b of x. So this is getting closer and closer to 1 over b of x quantity squared. As h goes to 0, b of x could care less. It's just b of x. As h goes to 0, this guy gets closer and closer to t prime of x. That's the definition of the derivative, t of x plus h minus t of x over h. As h gets close to 0, this guy can care less because it has no h's in it. As h gets close to 0, this guy gets closer and closer to b prime of x. All right, so I guess that tells me that this derivative is the same thing as b of x times t prime of x minus t of x times b prime of x. And just to make it look a little bit more compact, I'm going to put this back here. Pretty complicated. Again, I don't think of it as b of x times t prime of x minus t of x times b prime of x over b of x squared. I think of it as bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. So this is how I think about it. There's another way, I can't remember the exact way that students have said it, but in the past students have said something like low d high minus high d low or something like that. So I bet if you do a quick Google for the quotient rule and low D high or something like that, you'll find another way of verbalizing this. Regardless, I would not, again, I wouldn't think of it like this. It's too confusing. I would think of it like this. So as an example to apply this, let's find the derivative of 3 to the x over x squared. Again, without this quotient rule, you have to compute that limit definition, which would be horrific. So pause the video, see if you can apply the quotient rule to this. Well, hopefully you said it's going to be x squared, which is the bottom, times the derivative of the top, which is a to the x times ln of a, or 3 to the x times ln of 3, minus top, which is 3 to the x, times the derivative of the bottom, which is 2x, all over the bottom squared, which is x squared squared. So that would be that derivative. So again, if this were a live class, I would have all of my students in group zombie talk repeat this slowly 4 or 5 times. I would highly recommend doing that to help with the memorization process. And the product rule, quotient rule, maybe put them on index cards and then just look at them a couple of times a day for 2 or 3 days, and then you'll have them and you will never forget them. So today, in today's lecture, we looked at the product rule, first times the derivative of the second, plus second times the derivative of the first, and we looked at the quotient rule, bottom times the derivative of the top, minus top times the derivative of the bottom, over the bottom squared. And these can now be used to take derivatives of an entirely new class of functions, 2 classes in fact, namely products and quotients. So I hope you enjoyed the lecture today. Thanks for listening, and I will see you next time.